Hello, and welcome to Supercharge Your Game Design. I'm Marin, aka Algorithmer on the Scratch team. I'm a learning resource designer for Scratch, and I'll be your session facilitator today. A copy of the slides I'm sharing in this session is available on our website in our learning library, where you'll also find many of the resources I'll link to today. This is the fifth in our series of 6 sessions on leveling up with Scratch. Each session focuses on a different topic, and my goal with each session is to give you a variety of ways to approach creative projects on each of the 6 topics. The Scratch Foundation is grateful to AT&T for its support of this workshop series. We have partnered with the Achievery from AT&T to provide free beginner and intermediate creative coding lesson plans on a variety of topics for educators, caregivers, and learners. And I'll share some of those resources throughout the session today. To code along with me today, you can go to scratch.mit.edu and click Create, or log into your free Scratch account to save projects. For anyone new to Scratch, we have Getting Started resources on our platform and in our learning library with lots of helpful information. But a few quick basics. The Scratch Project Editor screen is where you'll create projects in Scratch. If you aren't already on this Project Editor screen, click the See Inside button, which is available on all projects. Any character or object you can code is called a sprite. To code projects in Scratch, start by dragging out a block from the block palette to the script area. You can click the block to try it. Then snap another block to it to build your script. If you chose when the green flag is clicked to run the code, click the green flag above the stage. You can choose your preferred language or color mode, original or high contrast, under Settings, and see our tutorials or debug buttons for helpful tips when creating projects. When logged in, you'll also have access to Remix projects, which is making a copy of someone else's shared project to modify. I'll highlight some remix opportunities in this series. Or share a project that you created inspired by this series, using the Share button to make your project public. We have a lot to talk about today, but I do want to share one slide to ground us in Scratch's creative learning philosophy. And for those newer to our workshops and creative learning materials, I encourage you to check out our Scratch Creative Learning Philosophy resource in the Learning Library on our website. As facilitators, we want to support playful learning and tinkering mindset values so that participants can engage playfully in projects that are meaningful to them and elicit joy, collaborate with peers to experiment, share, and celebrate ideas, allowing for multiple pathways of engagement to foster a wide diversity of projects and supporting different experience levels. We want to help them develop a mindset that is comfortable with the discomfort of getting stuck, making room for risk and iteration, as well as develop a mindset that thinks critically about strategies for getting unstuck, saving space for the process to start again, and help them imagine what's next. We often call this productive struggle. And this applies to you too. Remember that we are learners just as much as our learners. So, as we explore today, give yourself space and grace. And remember, it's okay to get stuck or feel uncomfortable. You don't have to have all the answers right away. Just a curious mind and an excitement to try new things. That is part of the process and how we develop and model a growth mindset for our learners. At the end of this talk, I really want you to be able to walk away with just a wide variety of resources and an understanding of our Scratch creative learning philosophy and creative learning spiral so that you can feel comfortable engaging with learners on these session topics and using Scratch in your classroom. Today, we're focused on thinking about how we can remix starter projects to add personalized touches and complex elements to our games. We are thinking about design considerations like what inputs to use and how to maybe make your projects more accessible to more players. We are going to consider how to add emotion, excitement, and urgency to games using sound and animated text, etc. And we are also, as always, kind of reflecting on these projects and thinking about how we can communicate and share as we spread them out into our greater Scratch learning community. Before we dive into leveling up with games, I want to acknowledge that games can really grow in complexity. And so a little pre-planning can be super helpful in the beginning. Some learners love to jump right in and create from a blank slate. They love that spontaneity of adjusting as they build, and that's fine. Others may feel more comfortable developing a more comprehensive plan first, maybe storyboarding things out. I always think that it's kind of nice before we start creating, especially something that can be really complex like a game, to at least take a few moments to brainstorm. It doesn't have to necessarily be in depth if that's not your thing, but I think it's always kind of nice to think about maybe what characters might we need, or what kind of settings might we want, or what kind of emotion do we want people to feel? What are the goals? And so we have this Scratch design journal that I think is a nice place to begin recording those brainstorming and maybe some sketches as we imagine and plan and iterate through the project's development. There's also helpful tips in there with debugging. There's some reflection questions. And so I really like to highlight this as a tool that you can use in the classroom. And especially if you are in an environment with limited devices where people have to wait in order to have some computer time to try these things, having this design journal is a great place where they can start working on their project and thinking through the considerations while they're waiting for time to get onto the computer itself. And so, something I definitely encourage is just taking a few minutes, asking yourself some of these questions about the goals, the object. Um, and we also have some All Blocks posters that are available from our learning library that you can download and print. Those could be helpful to just kind of put up around the room, or print out for users so that they can figure out what blocks are available as they're planning and thinking about it if, again, they're waiting for that computer time. Starting from a blank slate can be really intimidating for some learners. I am one. So it can be really helpful to utilize things like our interactive tutorials from the site, or maybe exploring and remixing a starter project if you have learners who are kind of stuck and aren't sure how to get started. And you'll notice that a couple of the activities I'm going to talk about today is utilizing that remixing process. You can also filter all of our learning library resources. So you could say something like games as the topic, and it will bring up resources related to elements of a game development, and game tutorials to explore. So wanted to highlight that learning library is new and it's there, and it could be really helpful as you're going through your journey here. To dive into games, really one important element of a game I found is knowing and controlling where objects are on the Scratch stage. So I think it can be a good place to start, especially if learners are unfamiliar with Cartesian coordinates, the X and Y axis and the X and Y positions that are shown in the sprite area on the project editor. We have an achiever unit actually called Cartesian coordinates, and we have another called coordinate reporter. And those are letting you experiment and kind of play with these X and Y coordinates. Or you could try out our starter project, our X and Y coordinates starter project, where we have some kind of plot points that we can go through. So here's that starter project. And if I click the green flag, the cat tells me where it is on the stage, and I can drag it around and notice how those numbers change. I can also input some numbers. So it tells me where it's at right now. How much should I change X by? Let's say 50. And how much should I change Y by? Let's say negative 30. And now it tells me its new location. And one of the things you can do is you can actually see inside and highlight how the plot points that the cat is calling out here are what's reflected down here in this sprite area. And so if you are wanting to introduce that topic and play around with Cartesian coordinates, that could be a really helpful starter for you. As we experiment and we're looking at the sprite's position and discovering the differences between blocks like move and change X or change Y, then I think this really starts to solidify, because there are often very similar blocks that can do what looks to be sometimes very similar moves, but can be slightly different. And so that conversation about what is change X, what is change Y, what's the difference between change and set, what is the difference between that and move, Um, Direction is another, if you are changing directions, how does that affect move versus change X? What about using the go to block? And so, as we are exploring those blocks in the motion category, this could be a really helpful exercise, getting familiar with those positive and negative numbers. Coordinates can also be utilized in a very unique and perhaps unexpected ways in projects. So, as an example, you could say record a sprite's X and Y positions as you move a sprite around, and then play it back as an animation. One thing I think about is kind of that idea of CGI motion capture where we're plotting a character's movements on the screen. So this is a little bit complex because we're now starting to think about using lists and variables, which are more of an advanced topic. But even just things like using the position of the sprite on the stage to change its size, or using the position on the stage to change the sound pitch. Those are other fun ways that you can engage with Cartesian coordinates that aren't just about moving a sprite around. Now we're utilizing that data about where the sprite is on the screen in order to make something happen. And so, one example of that here is this animation recorder that my colleague Eric made. So when I hold down the space key, I'm going to just I'd use my mouse to sort of jump the jump the frog, and then you can see it was repeated back to me after I let go of the mouse. And when I see inside, I can see that it is utilizing lists. It's recording lists of X and Y positions. I'm going to just do it again here. You can see it's sort of recording those in real time, and then it's cycling through those lists to play that motion back. So that's one example of utilizing those coordinates. This musical droplets project, I don't think I have my tab sound on right now, so you might not be able to hear this, but it is utilizing the where the mouse is clicking on the stage, its X and Y position in order to play a certain note, and it changes the pitch based on how high or low you are on the stage. So that's kind of a fun example, and this will be included in there so you can try this out yourself. Or here's this idea of position meeting size. So here, if I press my left or right arrow keys, as the cat goes closer to the center of the stage, it gets smaller, and if it goes farther away from the center of the stage, it gets bigger. And when you look inside, you can see that what I'm doing is setting the size based on its position on the screen. And so, again, some of these blocks are maybe a little more complex, but you can play with these. And they don't have to be quite so complicated as I've made it here. But something like size relative to position on the screen could really kind of set in motion or help students understand that idea of coordinates associated with numbers. Speaking of trying things out and getting inspired by experiments, like my weird little experiment there with position and size, when we are playing around with some of our interactive tutorials recently, two of my fellow Scratch team members shared some remixes of our Pong starter project that they were inspired to make. And one of them used two paddles, one of them used multiple bouncing objects, and I thought that they were just really fun examples of unique remixes of the standard Pong game that a lot of people have known and tried through our starter project and our interactive tutorials. These remixes give, a greater challenge to the player themselves. So it's not just a challenge for the person coding on the back end. They're also a bit of a challenge for the person on the front end who is playing these games, and also just a really neat show of how they've put some kind of unique personal spin on this standard project idea. And then, of course, there were just lots of opportunities for debugging. As we were even going through this, they were finding issues that they wanted to fix. So we think about how do you want to control the paddle? Are you using a mouse? Are you using keyboard keys? How do you want to control the speed of the paddle and the bouncing objects? Do you want to introduce modes or levels like beginner or advanced. Maybe the objects fly faster for advanced, or something else happens. What if just a single movement controlled both paddles? Was something that kind of came into my mind. And so, seeing that two paddle remix by my teammate, I was really inspired by that. But what I wanted to do, instead of have two paddles that I had to operate independently using maybe WASD keys for one hand and arrow keys for the other, I thought, well, what if one paddle controlled the other? So they were kind of always opposite each other. Um, Definitely a challenge for me as a player to try to operate, but also an interesting challenge for me as a coder to try to create. And so what I ended up doing was using things like absolute value. That abs block that you see there stands for absolute value, and the absolute value of a number is its distance from zero, and it's always expressed in a positive number. So here I'm starting to get some kind of cross curricular connections by using these advanced blocks, thinking about some mathematic terms and ideas. And so I'm using that in the context of this game. And this code sequence, uh, when one is going down, so when one's position is sort of in the negative y sphere, by using absolute, it makes the other one move north, positive. So now they're always moving opposite each other. And then I'm also using, you'll see like a join block in here to make things negative when I need a negative number. And so this was a lot of trial and error, a lot of experimentation. You'll notice that I did things like add code to show hide the stage monitors, so I could give the user control over how difficult it was. They could change that difficulty level, essentially the kind of the movement by working with those toggles. And and then I've also commented my code, because as I was working with this code, I wanted to be able to remember what I did here. Why did I make the choices that I did? How did I make this work? So if I come back to it later, I remember what I did, but also for anybody who's looking inside my project and wants to remix so that they can follow along. And so that's something that I also really encourage folks to do. And as you're creating more complex projects, it's just really valuable also to kind of reinforce concepts for yourself while you're also helping others. So, to make the Pong game, we used conditional statements. Many students first encounter those blocks in the control category and variables when they want to start creating games. And so, simple conditional statements like if then statements using a sensing block like touching mouse or touching another sprite can have a really powerful result, right? If you're touching another sprite, maybe you win a point or something explodes. Who knows what happens? But there's just a few blocks that you have to use to make something that can be really fun and interesting. And our maze starter project is a really great example of how just a simple if then statement could be used to, say, stop a sprite from walking through the walls in the maze. It has the opposite effect, right? So if you're moving forward 10 steps, but then you touch the color, in this case, you bounce back 10 steps. So it looks like you are not walking through walls. It's a very simple few lines of code, powerful result. And I think that that is something that is really fun and amazing when we are working with games. That touching color and reversing movement gets more complex, of course, in platformer games with like raised platforms where the sprite shouldn't pass through and it's jumping. And so I have a platformer starter project linked here, which the links again you will get in the slide deck afterwards, so you can test out all of these things. But it really takes a lot of experimentation with input numbers, block order, sequence. Sometimes there could be conflicting scripts that are running at the same time. So in order to get things working properly, you need to consider things running at the same time. So game development can get, as you can see, just really complex really quickly. And there's lots of debugging opportunities for you to think about. And so, you know, sometimes my platformers don't work quite the way that I wanted it to. Sometimes something can go through a wall unexpectedly or something else can happen. But I think that that is a really great opportunity to then consider pair programming, talk to your fellow students in the classroom, your fellow learners. Even if you are working solo on Scratch, you could always ask for help in some of the help forums or maybe in the comments below your project. Um, but part of getting something out in the world is even if it's still a work in progress, even if it's not quite polished yet, I think it's really important to be able to share, to be able to look inside of others' projects and kind of see how they approach something, because maybe that will give me an idea about how to change my own project. And so that in itself is a leveling up opportunity, a way to just break down someone else's code and engage with that as you're trying to debug your own or think about how to iterate and make improvements on your own project. It's just, I think, a really invaluable exercise that I always encourage. And games are a great example of times when often students try to do that for the first time. They see something cool, they have fun playing a game, and they want to know how to make it work so that they can change it to either make a cheat code or, or make their own version, personalize it. Things like, is something inside of a loop or not? What might be the benefit of that? What happens if, my variable doesn't get reset at the beginning? Things like that. We had a previous level up series all about conditional statements where we do a deeper dive into that. And then we will be talking about bugs and debugging in our next session. So I'm not going to go too deep into that here, but just wanted to highlight this is like, one of those times where debugging really starts to become something that they'll want to explore. And they might come to you and just remind yourself you don't have to have all the answers. As a facilitator, you're not necessarily meant to be able to fix the problem for them. It's really valuable to just be able to have them talk through it with you. Sometimes talking it out loud, they can solve it for themselves. Figure out where you can find other sources to go to for help. That's really the goal here. You don't need to be a master programmer to have students start to interact with games. In the platform or starter I just showed you, one of the things that it made use of was this concept of gravity in Scratch. So when the ball or the object is falling from one of the higher platforms, it gains speed as it falls down the stage instead of just falling at a consistent rate of speed. And that gives it a more realistic feel. And that is one way of leveling up your games, is to add that sort of like realistic elements and that bit of complexity to give it that different feel. We have a starter project called Gravity Example, and we have a bunch of Gravity resources including student-facing coding cards in our learning library. And I find that the concept of gravity is a really great place to start thinking about variables, because we're going to create a variable that will hold the velocity of the sprite. So the velocity is the speed of something in a given direction. We start with a velocity of 0, right, when it's at rest. And then we want to have the sprite move by that velocity, but gain speed, gain acceleration. And so if you see the code on the screen, you'll notice we are constantly changing that velocity just by a small bit. But you can see the difference between the red apple and the green apple. The red apple has no velocity, no gravity associated with it. The green apple has this gravity applied. And so you can see that the compounding effect of changing that velocity makes that green apple fall much faster. That makes the game more challenging to try to play if you're trying to catch said apple. But it also gives it that realistic feel. And now we're also making some connections with science and math. So those great cross curricular connections again that we can bring in even as we're creating something like a game in Scratch. Maybe you want to temporarily reverse the gravity. Flappy Bird is a very popular style of game that I'm sure you've seen, where pressing a keyboard key temporarily reverses the gravity. Those are wonderful examples of, more ways that you can add that complexity. Or like I have a project here that's linked, that's a bouncy plot where you can plot the course of a basketball as it is bouncing around. When it's going up, in this case, it's green. When it's going down, I have it showing in red. I'm plotting that information here in this graph, and then maybe I'm using that for some sort of a science lesson or a lesson about graph plotting and things like that. So just kind of a lot of different ways that you can approach this topic, uh, whether you're using it in games or outside of that, that I think can be really valuable. The gravity project that I showed, you might have also noticed that the apple kept repeating itself. You kind of saw it getting lighter as it was going along. So that's an example of using clones. That bounce plotter graph that I just showed you also uses clones. Clones are really nice because they um, they help us visualize the path of the sprite in those two particular cases. But in the case of a game like this game that I have on the screen, those clones let you create multiple copies of a sprite while your project is running. And then while that clone is produced, it has the same costumes, sounds, scripts, and variables as the original. And so it can really speed up your game creation. Instead of having to code, what is it, like, 25 of these falling orbs on the screen, I just have one orb sprite. And what I'm doing is having the clones instead change color, change size, randomly pick a position to start falling from, adding complexity to my game. So cloning really speeds up my game creation process by creating those multiple objects that I can collect. And again, it's just a more of an advanced topic. And we have some wonderful videos and coding cards all about clones as well that I would encourage you to check out. In many of these projects so far, you've probably seen that we are using operators. And so, arithmetic operators in Scratch are mathematical tools that perform calculations. They can report back if a mathematical statement is true or false. And then they can also perform functions on numbers to create maybe unpredictable values, or add two things together, subtract, divide, multiply. We have a achiever unit all about arithmetic operators if you would like to learn more. One thing that I really like is that fact that you can just quickly see equation results by simply adding an arithmetic operator to your script area, typing in the numbers, and if you click on the block, as you can sort of see, it's a bit maybe hard to see. It's a bit light there, but you can see it has the little results in a little box beneath that reporter block. So the length of an apple, it says 5 because there's 5 letters in apple. What's letter 1 of apple? It says A because that's letter 1. And so this is a wonderful way of being able to test some of these conditions that you may be adding to your game to see what the result is before you use them inside of a conditional statement or something else. I often find it's very helpful to sort of know what the program is seeing and to make sure that we're on the same page. And so this is one quick way that you can check those um, within your project as you are creating things. There's also blocks like greater than, less than, which are examples of Boolean blocks. They say true or false if you click on them, so you can see some examples of those there. And so these can become really invaluable, especially as you are creating complex games. Maybe you're checking to see if something is, the y position is greater or less than a certain number, and that triggers something to happen. Maybe you're writing a math game where you want to have them check the answers of the math equations for you. And so you're able to do that here. So lots of different ways that you can utilize operators in your projects. And one of those ways is to make a kind of a really eye-catching animated text that opens your game screen. Kids, are used to these really flashy sort of opening segments for games or movies, right? And I often see scratchers. This may be the sort of first step. So maybe they're not ready to complete the whole game yet, but they want to create this sort of opening excitement. And so they may create a teaser for their game using really eye catching text like this. Or they may, create something like "follow me for more," right? With things like this. And so something like this bounce text, this dynamic text can be just really important to both communicate information and guide players through the experience, display instructions, show scores or levels. You could, use text to tell a story in your game through visible character dialogue, or, again, just this exciting, visually exciting animated text to sort of set a mood. So we have a couple of achiever units where we go over creating this particular bounce text, create a text sprite, revealing a sprite, and the bounce algorithm. And you'll see that this is just one way that you could create this opening scene. It involves sine, cosine, some more advanced mathematical concepts. So you've got that, again, that cross-curricular connection that I love. But one thing that I always love to do, even if the lesson is sort of a step-by-step walkthrough of how you could create this, I always encourage experimentation and for folks to try things. So that could be changing color, playing with the values that are in these operator blocks to see what effect that has. Does it make the bounce bigger, smaller? Does it make the wiggle more? Does it create some sort of very unexpected behavior? Always something exciting that happens when you start messing with those values. And so just another way of making this personalized, making this your own. And so everything isn't just a copy, it's their own sort of unique creation, and just opportunities to sort of play and explore with so many of these concepts. Text generation is another way to add text to a game. So, in video games, you may see, dialogue that sometimes appears at the bottom of the screen, almost like closed captioning, that sort of talks you through what the characters are saying, or, maybe instructions on what to do in the screen. And so we have some videos and coding cards walking students through how they can create a text generator like this. It really is dynamic. It's something different than just using one of those say and think blocks. Those are great. I use those all the time, but sometimes students want a different look or feel for their project. And so this could be one way of accomplishing sort of a different look and feel for their game, is to use blocks like this. In this case, I'm using them to tell a very bad dad joke, but you could use them for a variety of things. And so definitely I would encourage you to check out the resources and follow along. It also is, again, a little more complex. Here you'll see I'm using a MyBlock custom block. That is something we also have resources there in our learning library about. I'm iterating through a list. And so definitely, again, just more layers of complexity. But for those students who maybe, have created their simple game and want to add some sort of a different feel, this leveling up, this could be a really fun opportunity. And then, here I'm iterating through a list in order to create this text, but that concept of being able to iterate through a list, an array, is a really helpful coding concept that they can use in a variety of applications, from storytelling to animation to here in games. And so, again, if your student is not necessarily 100% interested in games, a lot of the concepts that can be utilized in games can also be applied to a large variety of different styles of projects. And so just always love to highlight that because, of course, we love variety. Then, of course, we've got these new blocks. If you haven't seen these yet, these are our new face sensing blocks. And what I love about these is that it gets your body moving along with learning to code and creating a game. In this game, you can see I've created this game where I'm trying to catch fish. And instead of having my mouse or my keyboard keys control this shark that's trying to eat the fish, it is attached itself to my nose. And so I am using my body, my nose, in order to be able to catch the fish. These are AI-powered blocks. They use machine learning model to detect if they see a face and then where eyes, ears, nose, mouth, etc. are. This is an extension. So students can choose to use these AI blocks or not, but I do always love to highlight that it is a safe and fun way to use these blocks because they are not collecting and storing any data, no pictures of you, none of your video is being stored on Scratch servers. And so the only person who's seeing your video is you on your machine. uh, it also is not using your data to train. So it's already trained on millions of sets of faces, and so now it's just using that information to try to understand where your nose, eyes, ears, mouth, etc. might be. You could use these on things like informational projects, like food quizzes. That could be a fun game. You could, tilt your head and maybe change a costume, or pick a right food, or there's like a variety of things that you could do with these face sensing blocks. Um, and then, as an added bonus, while keyboard and mouse keys could be used, sometimes face sensing makes it more accessible because maybe you have dexterity issues, or maybe it's just you have more tilt control using your head than you would using keyboard keys. To use these face sensing blocks, you're going to go down here to the extension menu, and then you will choose this face sensing extension. We've made it an extension so that users have a choice whether they want to use AI or not. But once they apply it, then they'll be asked permission to use their camera. And once they've granted that permission, then when I click the green flag, you can see my face here on the screen. And this parrot, you'll see if I zoom in on the code, is attached to forever go to my nose. So as I move, it's determining where my nose is, and then it's using that information to attach the parrot. And then my goal is to try to catch these strawberries as much as I can. And so it's getting me moving. It's for those wiggly learners, this can be really helpful too, as sort of a mind body connection. And just a few blocks, and you've already got something really dynamic and interesting. And then you can sort of build upon that and make even more complex projects. Let me just grab one more here as an example. Here's this Vietnamese food quiz game that I developed. And so the cat's asking me for a particular item of food. If I tilt my head, I can sort through the different food options. And when I think I've got one that's right, let's just pick this. I grab it with my nose, I bring it to the cat. Yay, I got it right. uh, if I get it wrong, I know this isn't fuss, so we're going to go with this. Sad kitty. So here's both an informational project and a game, sort of all rolled into one. But I really love that these face sensing blocks give you this sort of very dynamic element. And yes, thanks to the Steam for Vietnam team who created the very cute assets that I've used in this particular game. Another way that you might control your project is to use the hardware. So your face could be one input. We've talked about keyboard keys and mice. But what about things like, say, the Makey Makey? If you're not familiar with the Makey Makey, it looks like this. And this is how the influencers do it. And so I just can use this, attach these alligator clips to home, and then to a particular keyboard key. And then I can connect these to any sort of conductive object. And now I've got these big um opportunities to have, like, big keyboard key presses, say, like pieces of cardboard covered in foil, right, so that it's conductive. Now I have these big buttons that I can push instead of just pushing my keyboard keys or my mouse. This could really open up accessibility options. Plus, like, who doesn't want to control a game with bananas? So so it's a really fun way of potentially controlling your game. Maybe you don't have the Makey Makey, maybe you have a microbit. Microbits, you could use the buttons on the microbit in order to control a game. You could use the tilt angle of the microbit to control a game. You could even use on the bottom of the microbit are these pins, and you can use them. They can function very similar to the Makey Makey, where you can connect pins and then connect them to, again, like foil covered cardboard or all sorts of things in order to operate a game. And just I have some examples here of these, like, big buttons that you could use. I'm using bottle caps here. Um, you could use this is the vernier sensor. I don't know if you've seen this one before, but in this particular one here, what I'm going to do when am I connected? Oh, yes, I am. Okay, so then I can use this push pull in order to move my rocket around. and I'm using the tilt angle. So if I can get it right, I can hit the bubble. This is hard to do live. And then I am, able to control this wacky little insane ship that everybody would get car sick on if they were driving with me, with the Vernier sensor. So just lots of different things that you could potentially do with, hardware. Another application that I really love is actually to, think about, creating your own game controllers. And so here's an example of a controller that I made for the Makey Makey, where, these are all conductive little attachment points where I can connect my alligator clip. And now I have sort of a game controller. I can go left, right, up, or down. And I just use Tinkercad software in order to design this. And then I 3D printed it out. That's another just a fun challenge where now you're kind of going cross platform. You've got Scratch, you've got Tinkercad, you're thinking 3D, you're thinking about accessibility. So lots of different things. This cat holder that I made for my microbit, same thing. I just, went into Tinkercad and designed something and printed it out because I was tired of holding the battery pack. So, lots of different ways that you can sort of interact with these things, that I always like to highlight. I'm going to keep grooving just because we're, as always, we always get low on time with these things because I just can't stop talking. But one of the things that I really love about this conversation about do I want to use face sensing, do I want to use microbits, do I want to use makey makey, is this idea of design considerations. And so, as people are creating games, one of the things you have to think about is there's a variety of inputs you could use, right? Keyboard, mouse, sound. We have a loudness block. You could use the loudness of your voice in order to control a game. These are all different things, video motion. These are all different things that could have a big impact. And so, one of the things I like to do is maybe let's take a few minutes and reflect about what kind of inputs would we want to use for this game and why. It could depend on who's my audience, right? Who am I designing for? Do they have any accessibility concerns like limited hand dexterity? Are there benefits of using different or maybe multiple inputs? Maybe you could do keyboard or mouse or keyboard or face. Um, does having one input give the user a different level of control over another? What's the goal of the project, right? So lots of different considerations that you can have as you are developing a game. And of course, then this also adds in layers of complexity and debugging opportunities. Funny how I do that a lot. But I love kind of having kids think through the why with their game, and that again kind of adds this nice level of complexity. And one of the things that I find, when I'm creating games, is sometimes there is like a really clear one over another. Just quickly, I will show. Uh, this game, for example, this is a Vietnamese boat float game that I made. This one uses my face, and I'm trying to it uses the top of my head, and I'm trying to navigate through a river, without hitting rocks. Now, it thinks I'm constantly hitting rocks because it's looking for a gray color, and I happen to have lots of gray in the background of my scene, I guess, right now, and so it's misinterpreting, or maybe it's seeing my hair, I don't know, as a rock. And so, again, these interesting debugging challenges sort of come up when you're using some of these things that you may not have considered. But the nice thing was that it used my head tilt in order to be able to control the angle of this boat, and that gave me a lot of quick, easy control. I have another version of this game that's linked in these slides here. You can see some of my examples down here. Um, and so you can test those out. The other one uses loudness. Maybe I can't control the loudness in my room, and so that will have an effect on whether I'm able to play the game successfully. Maybe using the keyboard keys to control the boat angle is just a little too finicky, and it doesn't give me the kind of control I need. So I kind of also like to challenge students. Okay, now that you've made this, maybe make a different version. Make a copy, make a different version, and see what happens if you change out the inputs, and what kind of effect does that have. So again, leveling up doesn't necessarily mean having to add a ton of complexity. It can also be these reflection opportunities, these debugging opportunities that come up as we are doing this. And then, of course, things like adding emotion and excitement with pitch. And so we have this game here. If you came to my first session on sound, I showed this one off. What happens in this game is that as the game progresses, you'll notice that there is a pitch change that happens. And so as the score goes up, so does the pitch. And that has the effect of making it feel more urgent. It adds a sense of excitement and urgency to the game that is just there simply because of the sound and the emotion that that elicits. And so I love to always think about it's not just about the game mechanics. It can also be about the sound. It can also be about the visuals. Is it dark and stormy? Is it vibrant and alive? And this can really have a dramatic effect on the game. So again, those sort of design considerations that you can use to finesse and add that sort of polish to your game once you've got it in a place that you think is where you want it. Health bars and timers. Also, speaking of urgency, I'm on my own timer here, and so I'm trying to be very cognizant of getting through my slides here. But health bars and timers can add that sense of urgency to a game. And so we have a wonderful achiever unit all about setting up your own and creating your own health bar, which I love. Also, since I'm not a super gamer, sometimes I crash out, minute one trying to play some of these games. So having, kind of a countdown, an opportunity to sort of fail and keep going through the game is very helpful for a player like me. And so something to consider, right? As you are creating a game, how can you make the experience nice for your user, give them more opportunities? And then in our backgrounds level up that we did earlier, I touched on scrolling backgrounds. Scrolling backgrounds are a really fun opportunity to kind of explore a world in a game. So you're not just statically in one visual scene. And so in this case, you have these characters who are walking through these worlds, and you can use keyboard keys to walk them back and forth. Or you can see on the one at the top there, it's more of a top-down view. So you're moving around the space, but from a different angle. I love to kind of add again that variety where maybe we're used to seeing games that are from this side view. So the top down could be a really interesting opportunity to sort of make something different happen. We have some cards here walking you through how you can create these, and I have some example projects included in that where you could try out these particular projects. But it's just again a nice opportunity to not only give a coding challenge, because these are a little more complex to think about and work through, but also just think about the design considerations, the emotion. What are your goals? What are you trying to what kind of a world are you trying to create for your player? As we close out our session today, let's look at Scratch's creative learning spiral. We have imagined, created, and played. So now it's time to share and reflect and iterate. Imagine again. We want to celebrate a culture of getting unstuck and celebrate what was learned from missteps. For those new to Scratch, it can be helpful to get stuck and experiment a bit with blocks before you, as the facilitator, share tips and tricks. It can be powerful to model getting stuck and showing that it's okay to not have all the answers. That productive struggle is really valuable. And debugging and iterating alongside your learners makes you an active participant as well, as everyone learns through play and tinkering. You can find our debugging resources in our learning library for more. As we think about creating, iterating on our work, or debugging, keep in mind that pair programming can be valuable, especially when you have groups of different experience levels or interests. Pair programming is a practice where two developers collaborate, sharing a keyboard and mouse to work on the same task or project. One person is the driver who creates the code, while the other is the navigator who reviews, guides, and thinks strategically. Roles are then switched frequently to balance tasks and share knowledge. Together, the pair can create rich and dynamic projects, while they have opportunities to teach and learn from each other and explore different solutions. The pairs could divide up the tasks in a project, A student interested in art might create sprites, or a student interested in music or Foley might create sounds or musical scores, while another focuses on coding. Or students could pair up at specific moments to debug or add additional elements together. If you have a Scratch account, your project will save automatically. If you don't have a Scratch account yet, you can save your project to your computer. Click File and then choose Save to your computer. Next time you want to work on your project, go to scratch.mit.edu and click Create. Then click File and choose Load from your computer to upload your project. If you have a Scratch account, you can share your project and add it to Studios. Click the orange Share button to share your project to the Scratch community. Click the See Project Page button on the project editor to go to the project page. This is where you can add instructions and notes about your project. Now, other Scratchers can see and interact with your project. We promote many pathways, many solutions, because often there is not one right way to create your project. Some projects may reach a higher ceiling and have more complexity, while others can show how you have stretched to widen the walls of what's possible. We encourage learners to have fun tinkering, work with their peers, and design something to showcase their passion, and then proudly share their project when they finish. You can see our reflection and sharing resources in our learning library for more. Speaking of reflection, learners can reflect on their project creation and process as they complete a show and tell sharing sheet, or project gallery walk, self reflection, and peer feedback sheet, which can be found in our learning library. Their peers are encouraged to leave feedback or comments on the sheet for the creator as they view the projects in a studio or participate in a gallery walk. Just note that learners need a Scratch account and access to the online editor to participate in studios. In addition to the resources shared throughout these slides, I've shared here some additional resources where you can find help, inspiration, and information. Dive into our learning library for a wealth of materials that continues to grow. I've mentioned resources on the Achievery during today's session. The Achievery platform connects K-12 students to a new world of digital learning. And the Scratch Foundation is partnered with the Achievery to provide free beginner and intermediate creative coding lesson plans on a variety of topics for educators, caregivers, and learners. On the platform, there are project guides and accompanying videos that support the exploration of Scratch. Lessons are perfect for those who may want more guidance or scaffolds to start. And Scratch units cover a variety of topics, so students can take the skills they learn and create projects about things that relate to their passions and interests, while engaging in playful exploration. You can sign up to access for free on their website. Thank you for exploring this webinar and our resources today. I hope today's session has sparked ideas and will inspire your own unique projects that speak to your passions and interests.